Hi friends, welcome to our channel Jayaditya Math Tutorial. We are doing a series of Ncert class 11th mathematics. As a part of this, we are now in the chapter sets. In our previous class, we have discussed the concept of empty set, finite set and infinite set. And in today's class, let us discuss some exercise problems related to empty set, finite set and infinite set. Okay, so this class will be all completely related to problems, so do watch it till the end. And if you are new to my channel, please do subscribe. If you like my class, please do like and share with your friends, and don't forget to hit the bell icon. So without wasting any time, let us enter. Right now, look here. So this is the first problem of your exercise 1.2. So what is the question? Let us see here. Which of the following are examples of null set? So here he has given 4 sets from which we need to show whichever is the example for null set here. Okay, Nana. So what is the first one here? That is set of odd natural numbers divisible by 2. Set of odd natural numbers divisible by 2. So see here, what is this term? That is odd natural number. Actually, odd number is a number which when divided by 2 leaves remainder 1. Right now, for example, see here, 3 is an odd number. If you divide 3 with 2, that is 2 ones are 2 and the remainder is 1 here. So when a number is divided by 2 and leaves remainder 1, then we call that number as odd number. So this number will be odd, and odd number is not exactly divisible by 2, right? Odd number is not exactly divisible by 2. Therefore, both the conditions are completely opposite to each other, right, Nana? So there will not be any odd number such that it is divisible by 2. Therefore, how many elements you can write in the roster form for this collection? No elements. So if there are no elements, then the set will be a null set. So you can easily say that this is null set. So simply also you can tell that odd number will be never divisible by 2. Odd number will be never divisible by 2. Therefore, the set is null set. And the next one, set of even prime numbers. Set of even prime numbers. What are the prime numbers, Nana? That is nothing but 2, 3, 5, 7, so on. And we will be having only one prime number, and which is even. So what is that one? That is 2. So set of even prime numbers includes one element, that is nothing but 2. Therefore, it is not a null set. So you can simply write here, it is not null set. Okay, Nana. The next one is very important here. See here, that is x such that x is a natural number. Okay, x is a natural number. That's okay up to here. And you see here, Nana, x less than 5 and x greater than 7. X less than 5 and x greater than 7. So x is a natural number such that it should be less than 5 and it should be greater than 7. Is it possible? For example, if you see here, so 5 will be here and 7 will be here, and here in between you will be having 6 now on the number line, right? So what is he telling? That x should be less than 5, it seems. That means x must be here and x should be greater than 7. That means x should be here. Is it possible for any number to be simultaneously at the same time? It should be less than 5 and greater than 7 here. So for example, let us see here. So for example, take the number 3. 3 is less than 5. But it is not greater than 7. For example, if you take 9, 9 is greater than 7 but not less than 5. So here there will be no particular value for x such that it satisfies both the conditions here. So what is the conjunction he has given here? And means it should satisfy both the conditions. That means the x should be less than 5 and at the same time x should be greater than 7. So there will be no natural number satisfying this condition. Therefore you can say that this is a null set. Clear now? This is very important. And next one, y such that y is a point common to any two parallel lines. For example, if you take any two parallel lines, actually what is the definition of parallel lines? The lines which never intersect each other, right, Nana? So you extend in both the directions, the lines will never intersect. So the point of intersection only will be the common point. For example, see here now, if the lines are like this, so you can say that this point is the common point for both the lines. But in the question, he is telling that there are two parallel lines and he wants common point. So there will be no common point here. So if you take any point on the first line and it is different from the point on the second line, So there will be no common point for any two parallel lines. Therefore, this set is also a null set. So in this, only one is not a null set, that is set of even prime numbers. That is, we have one element, that is 2. So the set which contains only one element is known as singleton set. So you should not forget this one. Okay, now this is all about your first question. Let us see the next one. Right, Nana, look here, this is the second question of your exercise 1.2 here. From the given sets, you should check whether the given set is a finite set or infinite set. So this is very simple. So let us do it each of the following one by one. Okay, what is the first one here? The set of months of a year. Set of months of an year. How many months do you have in a year? So that is nothing but 12 months we have. So 12 is a finite number, so you can tell the number of elements of the set, right? Now you can tell the number of elements of the set. Therefore, what kind of set it is? That is nothing but finite set. So this becomes what here? That is finite set. And let us go for the next one. It is in the roster form, you think. So that is 1, 2, 3 and so on. So here the last element is not given here, right? Now, so this is nothing but it is the set of natural numbers 1, 2, 3. It is continuing like that, right? So there is no last term here. We don't know where the set ends. Therefore, how many elements are there in the set here? So we cannot say that. So we have infinite elements in this set. Therefore, what kind of set it is? This is infinite set. Clear? And let us see the next one, third one. Here most of the students will be confusing by looking at the dots here. So see here, Nana, here also we have dots and even here we have dots, but here we don't have the last element, but here we have the last elements. That means, see here, these are also nothing but set of natural numbers, but only up to 100. Clear, Nana? So just by looking this, how many numbers are there in the set means you can easily say that the set is starting from 1 and it is ending with 100 and all the numbers are natural numbers. So how many elements do you have in this set? 100 elements you have. So you can say the number of elements here. So what kind of a set it is? That is nothing but finite set. And what is the next one? The set of positive integers greater than 100. Set of positive integers greater than 100. So up to 100 means you can easily say how many positive integers will be there. But greater than 100 means, again, see here, if you see the number line, if you have 0 here and if you have 100 here, and also you will be having some numbers on the right side of the 100 that is greater than 100. So you don't know how many integers will be there here. So we will be having infinite integers. Therefore, here also you cannot say a definite number for the elements in the set. Therefore, this set is also infinite set. Clear now? This set is infinite set. And the next one, what is the next one here? The set of prime numbers less than 99. So you know that below 100 there are how many prime numbers? So you should know this one. There will be 25 prime numbers below 100. And see here, 99 is also not a prime number. Okay, so below 99 also we will be having 25 prime numbers. So how many prime numbers do you have less than 99 in the sense? So you can easily say that there are 25 prime numbers. Okay, now, so there are how many prime numbers? There are 25 prime numbers. So here the number of primes are finite. Clear? So what kind of set is this? This is nothing but, again, it is a finite set. So in order to understand the concept clearly, do watch my previous class. There we have discussed the concept. I am observing most of the students, they will be focusing more on the exercise problems only, but not on the concept. But whenever you are preparing mathematics, the concept is very important. If you learn the concept in depth, you can solve any number of problems. Clear? So the concept is very important when you are preparing for mathematics. So please do watch the previous class. Okay, let us go for the next one. Right, Nana? See here, this is the third question of your exercise. What is the question? It is like the same previous case, but here the questions are somewhat tricky. Clear? So there will be some dilemma to decide whether the given set is finite or infinite. Let us see how the questions are. So what is the third question? Actually state whether each of the following set is finite or infinite, same as the previous case. So we should check whether the given set is a finite set or infinite set. So let us see how this will be. The first one, set of lines which are parallel to x-axis. Set of lines which are parallel to x-axis. So when you draw axis, so see here, Anna. So this will be your x-axis and this will be your y-axis, right? So what is he asking here? He is asking the set of lines parallel to x-axis. That means each and every line must be parallel like this, right? So how many lines can you draw like this? So you can draw infinite lines, right, Nana? So you can draw infinite lines which are parallel to what here? X-axis. You clear? So how many lines you can draw parallel to x-axis here? You will be having infinite lines. Therefore, you can easily say the first one is infinite set. Clear, Nana? So the first one is what here? That is nothing but infinite set. So let us see the next one. That is very simple. Set of letters of English alphabet. So how many letters are there in your English alphabet? A to Z. So how many alphabet you have? So you have only 26 letters, right? Do you have 27 or 28? So you have to discover those letters if you have. Therefore, you can easily say that in English alphabet we have only 26 letters. So you are telling a finite number here. Therefore, what kind of set is this? So this is nothing but finite set. So that is finite set. And the next one, set of numbers which are multiples of 5. Set of numbers which are multiples of 5. So if someone asks you to tell the multiples of 5, most of the students will be telling 5 1s are 5, 5 2s are 10, like that, up to 50 only, and they will be thinking that there are only 50 multiples. But sorry, only 10 multiples of 5, that is 5, 10, 15, 20, 25, like that, up to 50. But 55 is also multiple of 5. 5 11s are 55, 5 12s are 60, like that. So you will be having infinite multiples and finite number of factors, and always you should remember this one. How many factors? Factors will be always finite. Okay, for example, how many factors do you have for 6? You will be having only 4 factors, that is 1, 2, 3 and 6. So these are the 4 factors of 6. But how many multiples do you have for 6 means? 6 1s are 6, 6, 12, 18, 24, like that. So you will be having infinite number of multiples. Clear now? So whenever you see the word multiples, therefore you can directly say that this is infinite set. So what kind of set is this? This is infinite set now. And next one, set of animals living on earth. So again here you will be having some doubt. So whether the set of animals living on earth is finite set or infinite set. So see here, all the animals are on the earth. So if you start counting, after some years at least you can count completely. So here the number is greater, but the number is finite. See, clear, Nana? So this statement is same like what we have discussed in our previous class. There we have discussed one statement there. So the collection of men living in different parts of the world. Collection of men living in different parts of the world. So the number might be the bigger one, right, Nana? The number might be bigger, but you can say that the number of men is finite number there. Okay, so here also the number of animals will be finite. Clear, Nana? So the set of animals living on earth is finite set. Keep in mind. Clear, Nana? So this is what here? That is finite set. Clear? And the next one, the set of circles passing through origin. Set of circles passing through origin. Again, here also you should understand one concept here. What is the origin, Nana? Origin is nothing but it is the intersection point of both the axes, right? That is x-axis and y-axis. So see here, if you draw axis like this, so this will be x-axis and this will be y-axis. And what is the origin, Nana? It is the intersection point of x-axis and y-axis. So you can simply represent it with O. So what is our question here? Set of circles passing through the origin. So how many circles you can draw from origin here? So see here, like this you can draw one circle, and in this manner you can draw one circle, and also you can draw like this, you can draw one more circle like this. So you can draw one more circle, you can draw one more circle. So like this, how many circles you can draw passing through origin, Nana? So you can draw again infinite number of circles here. Clear? You can draw infinite number of circles passing through origin. Not only origin, passing through any single point you can draw infinite number of circles. If you want the knowledge of this concept more, please do watch the 10th class concepts where I have discussed about tangents and secants. There I have discussed completely the circles very well. So you see that classes from the playlist you will be having. Go to the channel, search for the playlist and search in the playlist. There you will be finding tangents and secants. So there you can easily learn the complete concept of circles now. So from a single point you can draw infinite number of circles. Even here the origin is the single point, right? Origin is the single point. So you can draw infinite number of circles passing through the single point. And today answer me a question. So I will give you 2 more questions and you give the answer in the comment section. I will see who will give the correct answer. Okay, Nana. Look at these questions. Take this as your 6th and 7th question. So what is the last answer for the last question? The set of circles passing through origin is infinite set, right, Nana? So let us see this 6th question. The set of circles passing through 2 different points. So what kind of set is this? Infinite set or finite set? Okay, or if you want to say null set or some other singleton set like that, you can also say that one also. So give your comment in the comment section for 6th one and also the 7th one. What is the 7th one here? The set of circles passing through 3 different points. The set of circles passing through 3 different points. So what is this kind of set? So infinite set or finite set or singleton set or null set, or if you have any other also answer, please do comment in the comment section. If you comment the answers in the comment section, I will be understanding that whether you are understanding my class or not. So please do comment in the comment section. And the other thing is, so if you give the comments or if you like the class also, it will be like a motivation for me. So please do like, share with your friends, and if you are new to my channel, please do subscribe. And if you have any doubts, you do comment in the comment section. And also with these answers, if you have understood this concept, please do give the answers for this in the comment section. And in the coming class, we will be discussing some other important concept and we will be doing some examples related to that. Okay, Nana. So let us meet in that class, and whenever you are watching a video, please do watch it completely. Let us meet in our next class. Till then, bye.